Okay, first one, remember to isolate your radical. Now, when you square both sides, you're always going to need to check your solution later because you just forced this to square to a positive. So solve it, bring this down. Now you have a cosine squared, get everything to one side, solve. If we're in 0 to 2 pi, you're all 4 quadrants. You get all 4 angles. Now, check them because you forced the square up here. These two will not work, so you must reject them. It always happens on a radical. On the radicals, you have to check. So make sure you check. So this is your solution to this. Same thing here. You have another radical. Isolate the radical. Square both sides. And then remember, once you do the square, you need to check. Solve, again, all 4 quadrants, solve it, and check them. And chances are the negative ones will not work. So reject them, and then all solutions, just set those two to 2n pi. Or, easier, just take the 1, the pi over 6, because the other positive one will work, so just leave it like this, where n is any integer. It's the tangent. This is for all solutions. Okay, this tells me half angle. That means I'm going to get half the amount of angles that I would have anticipated. So in 2 pi, if I got 2 solutions, I'm going to get half of that, 1, which means instead of my angle, it will have to double because I'm only going to get 1. So treat it like a regular angle, like a regular variable. Factor. If you have trouble, factor it. This guy has to come first. What happened here? This square doesn't go in there. So factor it. If you have trouble factoring it, it still looks like this. So factor x plus 1, x plus 1. That's your factors. The x is your cotangent, x over 2, or 1/2 x, whichever way you want to write it. Leave it x over 2 or 1/2 x, whatever you like. You only have to solve one of these because they're both the same. So solving for 1, keep your 1/2. Solve for, if it was plain old x, cotangent is negative in quadrants 2 and 4. It's the reciprocal of tangent. It's a 45-degree angle. So you're 3 pi over 4 plus n pi, where n is any integer. Now you need to get rid of the half. Multiply everybody by 2. 2, 2, 2. So your solutions, your all solutions, remember, you're getting half the amount of angles. So your angle has to double. So a 45, which this was angle 135, now went to 270. So here's my all solutions. If you want to go from 0 to 4 pi, turn it to the same denominator. It can only go up to 8 pi over 2. Add 8 pi to these, you're adding 2n pi, so you're turning it into 4n pi, so denominator 2. You're adding 4 pi to this guy, and then you're going to hit 8 pi, so you're only going to get 2 angles. If you would have gotten 4 in 2 pi, you're only going to get 2 in 2 pi. This is the max you can go to. 0 to 4 pi. So you get 2, which makes sense. You're half the amount of angles. This is a nice one, but you have 2 variables. Use your identity and replace the sine with the cosine. You cannot replace the cosine. Distribute, collect your like terms, and you should come out with this. And then you can factor. This is 2x squared minus 7x plus 3. The 2 can only go one way. The 3 can only go one way. They're both negatives. So I notice I need this to be 7. So I have to multiply this guy by a 3, this guy by a 1. And then put your pieces, put your cosine in. You do not have an angle whose cosine is 3, so reject that. And this was from 0 to 4 pi. I would just start it here. This is your pi over 3. This is your 3 pi over 3. This is your 6 pi over 3. Therefore, this is your 9 pi over 3. And this is your 12 pi over 3. So your 6 pi over 3, your pi over 3, then your 5 pi over 3, then your 1 more to go after the 6, your 7 pi over 3, and you're 1 short of the 12, you're 11 pi over 3. Or start it and just do 11 pi over 3 plus 2n pi, 5 pi over 3 plus 2n pi. And go one more cycle around. Don't forget to convert this to thirds. So add 6 pi. This will give you your 7 pi over 3. Add 6 pi. This will give you your 11 pi over 3. And your last one is also a half angle. Again, make sure you deal with that half angle. This is factorable also. 3 only has one set of factors. 1 only has one set of factors, and your signs are both negative. You can't miss this one. Keep your half in there until you solve it. This one has a little bit of an issue here. We have to use our calculator for this. It's approximately 18 degrees. So if I convert this to radians, I would multiply it by pi over 180, and I'd be approximately pi over 10 plus n pi because I'm coming across there. This one has it a little easier on this side, and you're only from 0 to 4 pi. Don't forget to deal with your fraction now. Multiply everybody by 2. So this becomes 2 pi over 10, which is pi over 5 plus 2n pi. This is an all solution. Add 2 pi to it to come out with your angles. You're halving the angles. So if you expected 2 and 2 pi, you now expect 1 and 2 pi. Your angle has to grow. And do it for this side too, where tangent is -1, it's a 45 degrees, and it'll give you plus n pi. Do the same thing, multiply everybody by 2, and you'll come out with your angles.